locus of points which is equidistant from two given points. The locus required here is the perpendicular bisector of the line joining the 2 points together. Then number 4, locus of points equidistant from 2 parallel lines. The locus is the third line midway between and parallel to the what? To the 2 given lines. So as far as this topic is concerned, these 4 points are very important and to be noted. So let's see UTME questions that are designed. Most of the questions here are theoretical. So in this aspect, we have these are the questions designed for this topic shown in figure 1.5D. The first question says that if P and Q are fixed points and X is a point which moves so that XP is equals to what? SQ. The locus of X is A straight line, B the perpendicular bisector of PQ, C a circle, D the bisector of angle PSQ. Look at that question. So we have, let's say you have a fixed point, you have a straight line. I'm just using as an example. You have a straight line such that P and Q, there are 2 fixed points here. There are 2 fixed points. X is a point which moves so that XP is equals to what? SQ. X is a point. So if you have these 2 points that are fixed and you use this, you mark an arc with your compass somewhere here, and you put it here and mark another point somewhere here, and you produce a line that divides this downwards, and let's say this point is point X. Now the question is now telling you that, remember that this one will definitely be what? A perpendicular what? Bisector of this what? Of this 2 fixed points, that's PQ. So automatically XP should definitely be equals to what? XQ. XP should definitely be equals to what? SQ. Then the question now is, which one will it now be? X is the locus of X is now what? Look at this. The locus of X is this. So automatically, what is it? It is a perpendicular bisector of what? PQ. So let's go to our option. A straight line, no. B, the perpendicular bisector of PQ. That is correct. So our option would definitely be option B, because this locus is a perpendicular bisector that will bisect these 2 fixed points, where this PX or XP will definitely be equals to what? SQ. So definitely our answer is option B, which is the perpendicular bisector of PQ. Number 2, in this regard, the question asks us to find the locus of a point which moves such that its distance from the line y equals to 4 is a constant. Let's say we have y-axis and we have x-axis. Then there is a point here. This point is 0, 0. That's when our x is 0, y is 0. So let's say we have another point somewhere here, because we are told that, or we're told that y moves from 0 to what? 4, because y equals to 4. So here, that means we have 0, 4 points. So let's make it a broken line. That's the one produced. So to a point, let's call this point P, which is our coordinate. Our coordinate is what? X, y. So and the distance between these two is that our K, which is a constant. So in this situation, if you are to determine the distance between these points, all we need to do is to say K squared, because that's the formula for calculating the distance, equals to what? That is y minus 4 squared plus x minus 0 squared. Because our y is 4, our x is what? 0. So in this situation, we have a scenario like this. So we now have k squared to be equals to what? Y minus 4 squared So this one will be plus x squared, because x minus 0 is x, so square, that's x squared. Then let's transfer this to this side. We have y minus 4 all squared to be equals to k squared minus x squared. So y minus 4 will definitely be square root, plus or minus square root of 4 k squared minus x squared. That's our y, because y minus 4 all square is this. Then y minus 4 will be plus or minus square root of k squared minus x squared. And meanwhile, what is our at a point? At a point where s equals 0, then we have y minus 4 plus or minus square root of k squared minus 0 squared. And what's 0 squared? 0 squared. So we have y minus 4 equals to plus or minus square root of k squared. Then we have, then in this situation, we're going to have, when this one comes to this side, we have y to be equals to, when minus 4 comes to this side, it becomes what? Plus 4 plus or minus the square root of k squared. And what's square root of k squared? That would definitely be what? K. So 4 plus or minus k. So we go to our option and pick the one that matches this. So if you look at our option, that will be no other option than option C, which is equal to y equals to 4 plus or minus k. Then, question 3. The locus of a point P, which is equidistant from two given points, S and T, is, so in this situation, we can see also that we have to look for that locus which is equidistant. So for it to be equidistant, this point, we put our compass here and mark a point. We come to this side, we put our compass and mark also another point. By the time we draw a line, so this one is not different from the one we solved earlier. Then we draw a line this way. So definitely this line will be a perpendicular bisector of this ST. So this will definitely be equals to this. And we call this, what is that according to the question? The locus of a point P, which is equivalent from two given points ST, is, so point P automatically, so that point is point P. So it will definitely be a bisector. It will be a bisector of the line. So a perpendicular, the first option is the angle bisector of PS and ST. No. B, a perpendicular to ST. It's not only a perpendicular to ST. C, the perpendicular bisector of ST. And the perpendicular bisector to ST. So that is, because this is what? A perpendicular bisector to this ST. So that is definitely going to be the option, because D, a line parallel to ST. No. So the answer will be option C. That is the perpendicular bisector to ST. Then question 4. The locus of a point P, which moves on one side only of a straight line XY, so that angle XPY is 90 degrees. A, an arc of circle through XY. B, the perpendicular bisector of XY. C, a circle. Then D, a semicircle. So if you look at this very well, the locus of a point P, which moves on one side only of a straight line XY. So let's say we have a straight line XY. This is a straight line XY. Then the locus of a point P, which moves on one side of the straight line XY, so that XPY. So P is somewhere so that XPY. So XPY. So I'm just trying to sketch that XPY is 90 degrees. So automatically, the locus will definitely be what? It will be an arc that will produce such that it will be an arc that will produce such that it will pass through this point X this way and also Campbell. So how is this one forming? It is definitely forming what? A semicircle. So it will be a semicircle. And which one has a semicircle? And that is option D, a semicircle. Now, question 5. Determine the locus of a point inside a square PQRS, which is equidistant from PQ and QR. So if you look at that, you discover that we have a square, and that locus is found inside the square. So let's say we have PQRS. Then that locus has to be inside, and the locus must be equidistant from PQ and QR. Take note of that clause. So for it to be equidistant, and it has to be inside. So you pick a point here and mark. Pick a point and mark. You can mark like this. Let's say the edge of that compass is here. Then you mark that point. Then you also pick a point here. A point here and mark towards this, like this. Although, because of the fact that I'm making a freehand construction, that is why you see it like this. Then this will definitely be, since it has been stated that it's equidistant, so it has to be, that means if you have the radius you are picking here is the same radius you are picking here. So at this point, when you mark a point somewhere here, is that same radius you are picking here, and you mark that same point. Then it is equidistant. It is equidistant, so that will be equidistant to what? PQ. Also, QR, that will be equidistant to that. You pick a point here, the same radius, you mark a point. You put let's say somewhere here, you mark a point. I don't know where the point you are marking. Then you put somewhere, but that will be the same radius, then you mark a point here. So what it means is that you will now see that if you are to join this, passing through the center of that your mark to this. So that point you are seeing that is passing through the center automatically is what? A diagonal. It is a diagonal of what? PR. So it's not, because another option can be diagonal to what? QS. But this time around, since it is equidistant, put it here, mark a point. Put it here and mark the same radius. Also here, mark a point. Put it here and mark a point. So it will definitely be a diagonal of what? PR, according to that sketch. Then in that situation, we have A, the diagonal PR, yes. B, the diagonal QS, no. C, side SR, no. D, perpendicular bisector of PQ. Is there anything like perpendicular bisector here? No. So there will be no other option other than what? Option A. Then the next question, the locus of a point which is 5 centimeters from the line LM. So the first thing we have to do is to produce a line such that the line will be what? L. Let's say these are 2 lines. Then we pick a kind of radius 5 centimeters. Then we mark. So we can put it here again and mark, because it has to be what? Equidistant. So pick a point here and mark. This point you are marking, or even with that 5 centimeters, if this is the point, then you have a kind of point such that if you make an arc, you can make an arc like this. From this point, you can make an arc of equal radius. You make another arc. So what it means is that this line, if you produce a straight line here, that straight line will definitely be parallel to what? LM. And the distance is what? The distance of this point from LM. Since you have picked a specific fixed radius, that is 5 centimeters. So that means the distance from this place, LM, to this point will definitely be what? 5 centimeters. So 2 things are happening. The distance will be 5 centimeters from LM, and the line that is produced will also be parallel to LM. So let's see the one that will suit that. Option A pair of lines on opposite sides of LM and parallel to it. B, line parallel to LM and 5 cm from LM. C, a pair of parallel line on one side. You have this line is parallel to this line. Look at this. Let's call this L2. So this, let's call this one L1. This L1, L2, this one is a pair of line on one side. This L2 is parallel to what? LM. That's the first thing. A pair of line parallel to LM, and is also what? Pair of parallel line on one side of LM and parallel to what? LM. So that one will definitely be a pair of line. You can see the line from LM and parallel to LM. So that option will be what? Option C. That will suit that particular answer. Then number 7. What is the locus of point equidistant from the AX plus BY plus C equals to 0? So I have to determine the locus. If you look at this very well, it's just a trap. What is going to be varying here is this. It's only the constant that will be varying. You still have the same equation. So let's go to our option. Option A line BX AY plus Q equals to 0. A line AX minus BY minus, that one is out. C, a line AX plus BY plus Q equals to 0. That is correct. D, a line AX plus Q equals to 0. No. So the only one that can match this is C. What you asked me that why is it not A? It is not A because in A, BX you are having is not B that has a coefficient. X has a coefficient of what? A. But they wrote BX plus AY plus Q equals to 0. Why the option C is AY plus AX plus BY plus Q equals to 0. So in this situation, X has a coefficient of A, not X having a coefficient of B. That is why the option A is correct. X is wrong, but the option C is the correct option. Then number 8, if the locus of the points which are equidistant from point A, from points P and Q meets line PQ at point N, then Pn equals, look at that question. So the question, we have to follow this question gradually. If the locus of the points which are equidistant from PQ, so that means we have two fixed points. We have a line, we mark it P, let's say this P, which are now here Q. Equidistance here, that means what we are going to do is, at this point that we have marked, we stretch it and mark a point. Then we come here again, we stretch it and mark a point. So in this situation, then we join this to that center. Let's join this to the center here with our ruler. Then we also join this to the center here with our ruler. Now, this line, if you produce this line straight down, it will definitely be a perpendicular bisector of this line. It will bisect this line. So in that situation, we've been able to draw what we are supposed to see. So now, they now say that from point P and Q meets line PQ at N. So it meets line PQ at N. You can see that now. Meanwhile, it is what? A perpendicular bisector. That means Pn should be equal to what? Qn. Take note of that. Because Pn should be equal to what? Qn. Since this one is a perpendicular bisector of this line. So automatically, the question now is, then Pn equals Qn. So go to our option and pick the one that matches that. So Pn will definitely be equals to what? Nq. Pn will definitely be what? Nq. Because this line, from this place to this place, will definitely be equals to from this place to this place. And our answer will definitely be Nq. That is option